I'm introducing a problem about predicting house prices using a simple machine learning model called DummyRegressor from the Sklearn library. We'll explore how it works and analyze its predictions. I'm posing a multiple-choice question. You'll need to understand how DummyRegressor with the mean strategy works to answer it correctly. It's all about predicting house prices, and the key is understanding the limitations of this super simple model. This statement correctly describes the core behavior of DummyRegressor when using the mean strategy. It's really simple. The model will predict the average house price from the training data for every single house, regardless of its size or location. Because the model's prediction is just the average price, it's very susceptible to outliers. A single very expensive or very inexpensive house in the training data will significantly shift the average, influencing all the model's predictions. This line summarizes the core of the problem. We're specifically focusing on the mean strategy within the DummyRegressor model. Understanding this strategy is the key to answering the question. It's all about that average house price. This question challenges you to understand how a simplified model, called DummyRegressor, with a mean strategy, predicts house prices. I'll explain that strategy in the next rows. This refers to a machine learning model from the Sklearn library. It's a super simple model. It doesn't actually learn anything complex. Instead, it predicts the same value for every house, the average price from the training data. I'll explain this more concretely in the next steps. This statement is true. Because the model uses the mean strategy, it simply predicts the average house price from the training data for every single house. It does not consider any house features. Think of it as taking all the house prices, adding them together, dividing by the number of houses, and then using that single number as the prediction for every house in the test data. That's super simple but not particularly accurate. This is also true. Because the model's prediction is just the average, a single very high or very low house price, an outlier, can significantly change the average and affect all the predictions. For example, if you have many houses priced around $500,000, and one house priced at $10 million, the average will be much higher than it would be without that outlier, and it will skew the predictions for all houses in the dataset. This problem focuses on understanding how Sklearn, specifically using the mean strategy, predicts house prices. I'll explain what that means and how it affects the predictions. The DummyRegressor is a simple machine learning model. When I use the mean strategy, it calculates the average house price from the training data. Then, it uses that average to predict every house price, regardless of the house features such as size or location. This statement is true. Because I'm using the mean strategy, every house gets predicted with the same price, the average price from my training data. It's like saying, every house costs the average price. This is also true. If I have a few extremely expensive houses in my training data, outliers, those high prices will inflate the average price. This means that my predictions for all houses, even those that should be less expensive, will be higher than they might otherwise be. The model is sensitive to outliers because the average is directly affected by extreme values. This statement is false. Accuracy is about how close predictions are to the actual values. This model ignores the individual house data. Therefore, it's highly unlikely to be accurate when the prices vary a lot. The prediction will be just the average, disregarding the actual house price variance. This statement is false. The mean strategy means that every house gets the same price prediction regardless of its size or location. The model ignores all input features in this specific strategy. The correct answers are C and D, confirming that the mean strategy in DummyRegressor gives the same prediction for every instance, the mean of the training data, and is sensitive to outliers in the training data because the mean is directly affected by them. I'm using Sklearn's DummyRegressor to model house prices. It's a simple model, perfect for a baseline comparison. This is the core problem. I'm using a DummyRegressor, a super basic prediction model, to guess house prices. The mean strategy means the model simply uses the average price from my training data for every prediction. This statement is correct, because I'm using the mean strategy. Every single prediction will be the same, the average house price from my training data. It's that simple. This is also true. The average is easily affected by extreme values, outliers. If I have one super expensive house in my training data, the average, and therefore every prediction, will be higher. Outliers heavily influence the model's output. The DummyRegressor with the mean strategy will predict the same average house price for every single house, regardless of size or location. I'm using Sklearn's DummyRegressor, a simple regression model. I'm using the mean strategy, which means my model will predict the average house price from my training data, regardless of the house's features. This question tests whether you understand how the DummyRegressor with the mean strategy works. Let's talk about outliers. Imagine one extremely expensive house in my dataset. That expensive house will inflate the average price, and my model will predict this higher average for every house, even those that are much more reasonably priced. The mean is easily influenced by extreme values. That's what makes my model sensitive to outliers. Because I'm using the mean strategy, my model's prediction will be the average of all the house prices in my training data. Every single prediction will be exactly the same, the average house price. It's a very simple prediction, not affected by the specific size or location of the house. I see you're focusing on the DummyRegressor with the mean strategy. This is a simple model. It just predicts the average of the house prices from your training data, regardless of any house features like size or location. It's like saying, I don't really care about individual house details. I'll just guess the average price for all of them. I'm excited to help you understand Sklearn. We're tackling a conceptual question about it, not complex code or calculations. We'll focus on understanding how it works. Get ready to learn. I'm addressing this statement. Will this regressor's accuracy change if there is a wide range of house prices? The answer is no. The model will stubbornly predict the average, ignoring how spread out the prices are. High variance in the data would only mean that the DummyRegressor's predictions are likely to be poor. Let's examine this. What happens if there's one extremely expensive house in the data? I want to highlight that the average is impacted by extreme values, so this model is sensitive to outliers. That one pricey home would pull the average price up, affecting all predictions. Here we will discuss whether the model makes varying predictions for identical houses. It does not. The beauty, or drawback, of the mean strategy is that you get the same prediction every time. This hits the nail on the head. That's exactly what the mean strategy does. It's all about that average house price. Every prediction will be identical, all equal to the average price from the training set. This sets the scene. We're dealing with a DummyRegressor in Sklearn that makes predictions of house prices using the mean method. We'll evaluate several statements about the predictions it makes. This is the core question. I'm using Sklearn's DummyRegressor to predict house prices, and I want to understand how accurate the model's predictions are. I'm using the mean strategy, which means the model will use the average house price from my training data. I'm testing your understanding of how this simple model works. This is the key. DummyRegressor is a simple model from the Sklearn library. The mean strategy means the model will predict the average, mean, of the house prices in the training data, regardless of any other information about the houses. Think of it as a really basic, always predicting the average model. It's useful as a benchmark. Other models should perform better than this one. This indicates that I'm answering this question by selecting the best choice from a list of options. I need to consider each option carefully and understand the behavior of the DummyRegressor with the mean strategy. This is correct. Because I'm using the mean strategy, the model will ignore all the house features, size, location, etc. It will simply predict the average house price from my training data for every single house. This is also correct. The average, mean, is affected by outliers. If there's one extremely expensive house in my training data, it'll significantly increase the average, and thus, the model's predictions. The model's prediction for all houses will shift up because of this one outlier. This is wrong. With the mean strategy, the model will always give the same prediction, the average price from training data. This makes sense, given that the model doesn't actually look at the features. This is false. Accuracy isn't really relevant to this simple model. High variance, lots of spread in house prices, means this simple model will be inaccurate. It's a bad model for high variance data.